Hello everyone, it's Songwei, and today we're going to be talking about lists. So list is a kind of interface in Java that allows you to sort of have ordered collections of things. So under that category of lists, one of the types is an array list. So what is an array list? Well, we've talked a little bit about arrays in the past, and so an array list is kind of similar. It's, in a sense, it's like a dynamic array. So arrays are immutable. Once you make them, the size is set. You can't change the size, you can't like add or remove elements. But ArrayLists is a dynamic array, so you can add and remove elements and the size changes accordingly. Like an array, it's still an ordered collection of like things, so you can only have like one type of thing in the array list. You can't have like strings and integers and like doubles. You can't have that. But one thing to note about array lists is that you can't have primitives. So a little bit more about not having primitives. If it doesn't have primitives, then what does it have? Well, instead of primitives, it has something called a wrapper class. So this is when Java automatically wraps a class or an object around a primitive, and this is called auto-boxing. So Java automatically converts primitives to the wrapper class, and when it converts it, it's called boxing, and when it quote-unquote unconverts it, it's called unboxing. But overall, this process is called auto-boxing. So as an example, int will become integer wrapper class, boolean becomes boolean with a capital B, and double becomes double with a capital D. So primitives are normally lowercased, and the wrapper class objects are normally capitalized. And when you're creating an array list, you have to create it with wrapper classes, not primitives. So now let's get a little bit into actually making and using an array list. So to create an array list, we want to do, and remember the wrapper class, so we'll make one that's integer, and we'll call it nums. And you'll notice that we don't put a size in the array list, unlike how we do for an array, because we can change the size anytime, and so we don't have to set a size beforehand. So that's the creation, and to add something to it, we just do and this adds the number 10 into the array list. We can add another number, like so now we'll have 10 and then 6 in the array list. To retrieve elements from the array list, we use a method called get. And in get, we'll put the index of the element that we want. So if we put 0, then this returns 10, since remember it's zero-based counting. So 10 is index 0 and 6 is index 1. And if we want to add elements to a specific spot, then we actually have another add method. This is, remember, called method overloading, where it's the same name method. The method has the same name, but it has different parameters, and so it can serve slightly different purposes. So in this one, if we do 1, 12, then this will add the element 12 into index 1. So now this array list will look like this. We've added 12 into index 1. And to remove elements, we will use a method called remove. And this is where the index of the element that we want to remove goes. So then we will be left with 12 and 6 because we're removing the 10 at index 0. And finally, or not finally, we have a method called set, which is kind of similar to add, but it replaces the element with it as well. So if we did nums.set 1, 9, then this would set the element in the index 1 spot to 9. So now we would have 12 and 9 because 6 is in the index 1 spot and we've replaced it with 9. And finally, we can also always get the size of the array list, and this would just return 2 since we have two elements, 12 and 9. Next, we have linked lists. So what is a linked list? Well, a linked list is a sequence of nodes. So this is a little different from how array lists work. Even though it is mutable and you can change and add elements, the way we do it is a bit different. So each one of these little boxes is a node, and each node holds its own value and the address of the next node, which is why it's sort of a chain or a sequence of nodes. So at the very start, there is a reference that has the address of the first node here. And from that point on, each node has the address of the next node along with its value. And at the very end, the last node's next is just a null. So that's when you know that it's the last node. The last node is also called the tail node, and the first node is also called the head. This also starts at index 0, and there are two kind of key terms that we use. The first term is the successor, which is the next node in the sequence, and the next term is the predecessor, which is the previous node in the sequence. And when we get the size of a linked list, that's just the number of nodes or the number of elements in the linked list. And the way we use linked lists is kind of recursive. So once we get sort of the first node, or we apply something to the first node, we'll kind of do that action to the rest of the nodes recursively using the address that we get from the first node. So for example, if we call this list as list, then if we do list.getValue, then we get the value stored here since it's the very first element. If we do list.getNext, then we would get the address of the next node, which is stored here since that's the address of where the next node is. There are a couple different types of linked lists. So this linked list here is a singly linked list, which means, or a singular, this is here is a singly linked list or a singularly linked list, which means it just holds the address of the next node and it holds its own value. But we also have doubly linked lists. So doubly linked lists are lists that hold its own value, the reference of the node after, and the reference of the node before. So we call that the node's next and the node's previous. Each node has a value, a link to its successor, and a link to its predecessor, and the header points to the first node in the list and to the last node in the list, or it contains a null. So the previous of the first node is null, and the next of the last node is null, and of course null doesn't have like a previous or a next since it's just null. We also have a circularly linked list, and we can either have circular doubly linked list or circular singly linked lists, and that is basically where the last node has a value or a link to the first node in the list. So instead of this being null, this would instead have a link to the very first node. And the same would apply to a circular doubly linked list. So what are the benefits of using a doubly linked list compared to a singly linked list? Well, it can be traversed in either direction, which could be necessary in some cases, and some things like deleting a node or adding before a node become a lot easier because you have the addresses of the nodes before and after. But doubly linked lists require more space than singly linked lists, and they're slower because you have to deal with more links instead of just one link. And again, because of that, there's also a greater chance that you have errors or mistakes in the way you arrange the links because you have to change them around more than you have to do with singly linked lists. So let's get into how to create a linked list. So to create a list, a linked list is pretty similar to the way we make an array list. We declare the linked list, and just like a linked list, the type is a wrapper class. And just add elements. So for example, we'll just add a couple of numbers. And we also have a get method, and this gets the element at a certain index. And we can also set numbers similar to the array list. There are also lots of other methods like add first, add last, size, remove first, remove last, remove, has size, etc., etc. So this was kind of a basic introduction to ArrayLists and linked lists, and you can always go do more on your own by looking into the linked list and the list node classes themselves, and maybe even coding some of your own methods. But I hope you learned something today, and I'll see you next time. Bye!